This beautiful Shelby Cobra is actually a 3D printed replica, and these radical 3D printed cars are lighting up the auto industry like never before. Get ready, we are about to check out 8 advanced 3D printed vehicles. What's the next industrial revolution in automotive development and production? German company EDAG believes it will feature 3D printing. With the release of their Genesis Autobody prototype, EDAG showed how mimicking nature through the 3D printing process could be the best approach to structural design. As the natural evolution of the Genesis body to a complete vehicle design, EDAG released this extreme sports car prototype, the Light Cocoon. The Light Cocoon combines the bionically optimized 3D printed structure of the Genesis with a weatherproof textile outer skin and backlight technology. Modeled after the natural framework of a leaf, the outer skin exhibits maximum lightweight structural requirements. Believing that the digital revolution will turn their vehicles into functional living environments, EDAG has teamed up with Bosch to produce another amazing concept car, the Soulmate. This spectacular 3D printed creation seamlessly integrates the car into the digital world of the driver, navigating not just through the traffic, but also through the driver's daily tasks. Light can be used both outside and within the car to communicate visually. Through biologically influenced 3D printing and digitally enhanced technology, EDAG's amazing concept cars could have an incredibly bright future. As the first ever car to be designated as a U.S. federally recognized historic vehicle, the Shelby Cobra stands as a legend of the American auto industry. In honor of this iconic car's 50th anniversary, the U.S. Department of Energy's Oak Ridge National Laboratory has succeeded in creating a 3D printed replica, meant to demonstrate modern 3D printing manufacturing and rapid prototyping technology. This beautifully crafted machine does the original Shelby Cobra proud. The car is intended to serve as a rolling laboratory for the testing of new power plants, fuel cells, and other systems. Thanks to Oak Ridge's big area additive manufacturing machine, it took only 24 hours to create all of the Cobra's 3D printed parts, and 6 weeks to complete the entire car. The ability to design and print a vehicle as beautiful as the Shelby Cobra is nothing short of amazing. Believing that cars have been made the same way for far too long, Arizona-based Local Motors is doing something about it. Check out the ThreeD, the world's first 3D printed electric car. A joint project between Local Motors and Oak Ridge National Laboratory. This amazing two-seater was 3D printed and quickly assembled at the 2014 International Manufacturing Technology Show in only 44 hours. Spurred on by this unbelievable accomplishment, Local Motors is at it again. This is the LM3D Swim. Destined to be one of the first 3D printed electric cars you'll actually be able to buy. Having taken only 2 months to go from the initial design to a working prototype, the company hopes to have the LM3D Swim ready for sale sometime in 2017. The car sits on a 4-inch lower hull protecting the electric drivetrain, which is made up of a core of battery cells. The beach buggy appearance is only one configuration of the completed car, as the design allows for a broad range of variations to the outer shell. A sporty 2+2 coupe is also on the drawing board. With the LM3D Swim, Local Motors promises even greater innovations to come. We've already seen what Local Motors can do when it comes to designing and manufacturing innovative 3D printed vehicles. So what could they possibly do for an encore? This. Meet Ollie, your friendly neighborhood 3D printed mobility solution. This human-supervised self-driving minibus exhibits an entirely new way of thinking about transportation. With Ollie, if you have a smartphone, anywhere you happen to be becomes a bus stop. Getting a ride will be as easy as alerting Ollie to come pick you up. Streamlined and boxy on the outside and resembling a ski lift on the inside, Ollie employs the power of IBM's Watson supercomputer to speak to customers while they ride. Local Motors envisions fleets of 3D printed Ollies being used for on-demand city transport, moving workers around corporate grounds, and shuttling students around campus. Controlled from a central communications hub, the all-electric Ollie will use cameras, LiDAR, and an array of sensors to drive itself around a predetermined area. Safe, stylish, and efficient, 3D printed public transportation vehicles like the Ollie may soon become a familiar sight. This fabulous beast is the Blade from Divergent Microfactories. Previously featured on Freeze HD, Divergent claims it to be the world's first 3D printed supercar. Records aside, this is one awesome looking creation. The company's independent studies show their manufacturing process to be far more environmentally friendly than traditional means. While that's wonderful news, we tend to be a lot more impressed with the Blade's breathtaking profile. The chassis, which the company calls the Node, is made by melting aluminum powder into form by using a laser-based 3D printing system. To secure the Blade's performance, Divergent turned away from an all-electric drivetrain in favor of a 700 horsepower gasoline and natural gas hybrid turbo engine. At 0 to 60 miles per hour in a brain-bleaching 2.5 seconds. We'd say it definitely earns its supercar status. Fear the Blade. Once again, the Oak Ridge National Laboratory is leading the charge in advanced technology with the AMI project, meaning Additive Manufacturing Integrated Energy. This project greatly utilizes both 3D printing technology and newly developed energy transfer systems. The energy we use in our vehicles and our homes has always been completely separated. Using a sophisticated system of wireless energy transference, AMI integrates how we generate, use, and store energy by sharing it between a building and a vehicle. By employing 3D printing to create both the vehicle and the building, the advantages inherent in additive manufacturing are also clearly demonstrated. Once both items have been assembled and electrically outfitted, the energy integration process can begin. To power the building's lighting and appliances, energy is captured by the building from the public energy grid. Solar energy is also captured by the building's solar panels and stored in batteries. Once the 3D printed vehicle positions itself on the energy pad, power can be wirelessly transmitted in both directions between the vehicle and building as needed. By demonstrating how the use of 3D printing can be coupled with integrated energy systems, the AMI project redefines both energy and manufacturing. Would you ride a plastic motorcycle? This is the gorgeous 3D printed motorcycle from TE Connectivity, a Swiss company that dabbles in a myriad of emerging technologies. Printed with the same impact-resistant ABS plastic used to make Lego bricks, this experimental bike is modeled in the legendary Harley-Davidson Softail design. While the drive belt, electronics, engine, bolts, and braking system were made through traditional manufacturing, the remaining parts and frame were all 3D printed. Created through basic trial and error, the frame can support 2 adults with a total weight of up to 400 pounds. The entire bike, weighing only 250 pounds and measuring 8 feet in length, required a staggering 4,000 hours to finish at a cost of $25,000. Because this groundbreaking motorcycle was created as a show bike for demonstration purposes, speed and performance were not emphasized. In fact, the 1 horsepower electric motor gives this 3D printed prototype a top speed of only 15 miles per hour. Still, TE's point that a good-looking full-size motorcycle could be created through 3D printing was made, and with style. For many who attended college, memories include countless hours in drab old buildings, libraries, or boring classrooms. For these lucky students at Singapore's Nanyang Technological University, much of their time was spent building this innovative 3D printed car, the Nanyang Venture 8. Created as a project for entry into the 2015 Shell Eco Marathon Asia competition, the students succeeded in demonstrating that 3D printing technology can be used to custom design cars. Though the chassis and many other parts are made of metal and carbon fiber, the body and outer shell is composed of over 150 3D printed parts. The body panels have a honeycomb design on the inner surface to ensure the Venture 8 is rigid and strong enough to withstand the anticipated loads. Also featuring vertically rising doors, the 93-pound Venture 8 proves that through 3D printing, vehicles can be manufactured in less time and at far less expense than previously possible.